Cool. I hope everyone is doing good. Yeah, all the stuff that Alex spoke about, I'm going to talk about it a bit more. But hopefully this time we're gonna make it even more simpler because there's JS in that word, which is JavaScript. Yeah. But to gauge from the audience, who here has touched HTML? So basically, all of you guys are machine learning experts. Because with Tensorflow.js, Tensorflow.js basically allows JavaScript developers to be able to use machine learning models in the browser, in your phone, or anywhere JavaScript can run. So Tensorflow.js, before Tensorflow.js, or before, let's just say before, you had to know Python or know R in order to do anything related to ML or AI or anything close to that, until we had like ML5.js and lately Tensorflow.js and some great technologies coming from Google as well, with MediaPipe as well happening in the background. So finally, us JavaScript developers can actually finally touch our hands on that sweet ML juice. So my name is Siso. Basically, I'm a mobile developer at Cricket. I work mostly with React Native, which is JavaScript in the background, for those who don't know. So basically, I make apps. And but I'm also like kind of passionate about anything AI and ML. I'm not an expert at it, but I just like to poke around. So I thought it would be fun just to talk to you guys and chat and see what we can do with ML. Basically, what you see there is like, it's not really clear, but there's an image in the corner there which just shows the same thing. That the first layer is the layers API, the second one is the core API. Core API, that's where Tensorflow.js fits in because it removes all the complexity which you get from the layers API, just the carriers model. For those who do Python, they will be familiar with the carriers model. So with the core API, it allows us to work with the browser and work with the client, which is Node.js. But what are some of the things you can do with Tensorflow.js? So basically, most things AI can do with Tensorflow.js, but then mostly we see most of the work evolving around image classification, like something that Alex showed us. Natural language detection. If you use Google or Gmail, like spam, anything like that, that's natural language processing anymore. Audio recognition, and also in games as well. Because who likes to play, like, you need more challenges, so they use ML to give you more challenges when you play games. And you can actually find out more about some of the stuff that you can do from the TensorFlow Hub, which is like a website where you can find out more about the different models. Most of them are hosted there, so you can easily just import it into your project. So how does this relate to remote eye care and all of that? So basically, I think I was speaking with my optometrist, and something came up in the discussion that, like, majority, when you look at Africa, about 73% of people in Africa don't have access to eye care or even access the funds as well. Basically, it's there. So, and then, like, at the time, like, more about my health than that. But afterwards, got me thinking. I mean, I know JavaScript, I know coding, I know how to make things. How about we do something? What can we do, or what can I do to actually, like, decrease this number? 72% is a lot, eh? So it just got me thinking. One of the first things I thought about was, okay, I know JavaScript, I know, basically I can use some sort of AI ML model which I can use and do something exciting, or something that can at least bring out a number. And that's why I came up with the idea. It's something which is still in the process, But then like there is a North Star. The North Star is to actually get something whereby you can actually be able to upload pictures and use your video and be able to get some sort of detection or some sort of like early report of that, like maybe you should go to your optometrist or this is exactly what's happening with you. So how can we use ML or AI to help with this problem? The first one would be like the difficult one, like to say difficult, the first top one, and easier, the second one. Whereby people can actually upload images of their iris or like their eyes, and then like basically that will be run through a model which has all possible diseases or infections which happen to the eye, and then you say automatically, okay, you have this certain problem. And that actually is more difficult. Doing the actual training of a model is actually easier, but actually getting the data, that's the difficult part, because you actually need to be able to have access to like thousands and thousands of documents of people who have problems with their eyes, and then you can train the model through it. But I'm going to show you an example just like in a few minutes about how you can do something similar, but using JavaScript, but it won't do the eyes, but it will be something similar. Another one would be to do something even simpler. That's about detection. Basically, there is that simple test called the training eye test. Basically, they show you a bunch of E's, and then they tell you this is pointing to the left, pointing to the right, pointing down, and then based on the results of that, they can tell you, okay, your eyesight is, let's say, your left eye, your right eye has a problem, or you need to do more, need to go to the optometrist for more details. So I thought like maybe we can actually do something like that, because that's much simpler for us to do. Before that, let me show you, let's see some code about how can you actually train a model in JavaScript using Tensorflow.js. And the best part about it is that you can actually train the model in the browser, so you actually don't even need to have some complicated setup. But obviously, it's always recommended that you use the server to something like Node.js. If you guys know about Node.js, you can actually use Node.js to train the model. So let's see some code. Can you guys see the screen? It's actually not that great. Okay, that won't do anything. So I'm just going to zoom in. But basically, what we have here, some people might know about this code. This is an iris classifier. So basically, what it does is that iris is a type of flowers that I don't think they grow in South Africa. But then what happens is like the different types of them. So I have another picture here. Okay, well, I think this would be better because I have like a version of it. I'll post it somewhere, maybe on my Twitter, so you can actually go through the code yourself. Because I did post a Medium post of this. So we have these 3 different plants here, which are called the iris. So basically, we want a model which will be able to recognize what type of plant flower do we have if we upload, give it like details. For example, I can say the size of the petal, the type, the shape. So you give it those features, and then the model is going to tell you this is the type of plant that you have. So it's something similar. So if you look at the example about eyes, we can give it certain features or characteristics of the eye, and then you say if you see these features, then this person has this certain disease, or this is what the person is suffering from. So in this case, we just have the flowers, and want the model to classify them. So what I'll do now is I'll just run that in the browser. So it's simple as just open Live Server, or use, if you know about Simple Server, similar thing. Let's go to edits.html, which is a simple HTML file. So I'll just inspect there. Then you'll see some numbers going down. Basically what's happening there is that we're actually training the model now. And you'll see that we have a loss here. So loss, and then we have this word epochs. So basically it's the number of iterations as we're training our model. And then what we see here now is the alert is actually in the code. I am giving it a certain flower at the end. So I'm giving it a test file, which is on this line here. We're saying that we want it to detect from that tensor what flower is there. So and then it basically can tell us it has never seen this set of features, but it's able to predict that that's the flower that we got. And you can actually do the test of other parts as well. So I have this one on my Twitter account. So if you're looking to play around with it, you can just go to my Twitter profile. There's a link to it there. So it's pretty cool that everything here is actually HTML, so you can actually see it, and it's actually doing the training on the browser. So I'm actually go back to the slides. So that's that. So, and then the second part we talked about was that, are we able to, a more simple way would be to use pose recognition and allow a person to use the training feature, which is what you see at the bottom there. Basically, the idea is that a person is going to stand a certain distance and be shown letters, or which is the E in this case, in different directions, and then the goal is for them to say, okay, this is pointing left, pointing right. The letters change, and because if you use this app on your phone, you won't be getting the true scope because you're too close to it. So you need a certain distance to be able to do this test. So that's why pose recognition will work best in this example. So I'm going to show code for this as well. Basically, I'm just looking for something similar to this, whereby you're going to be able to say left, right, in the center, and so forth. So let me do a live demo, if it's possible. But it's something which is still just in the works, nothing published at the moment. But hopefully I can show something here. For anyone who recognizes or knows React, this is React right here. So everything you see here is React. So I'm going to go young start to start model. And then I should appear here. So it's me. So what I'll do is just see if I can just start. So automatically you'll see that there's an arrow which is going to be able to point where my hands are pointing. It's going left, up, to the left, to the right, going up, and then going down. So this in this demo, you can actually see that now you can actually give this app to any person who's going to be anywhere in Africa, and then just asking them that this is just point to the left, point to the right, point up, and then that way you're going to be able to go through the test and see, okay, this person has been able to recognize these letters at this distance, and then that can be taken to an optometrist, or we can safely say you actually don't need to go to just because you have 20/20 high vision. So that's the ultimate goal. So if I just start this, and I go to say, for example, now you kind of see, so the idea is that I'm not sure if it will be possible to do it here. going to say something like this, whereby we want you to be able to say where the E is out. Cool. Yeah, the idea is to be able to show which side the E is pointing, and then you can see that the direction of the E is changing. Also, you have points at the bottom as well to show how many letters you got right and how many letters you got incorrect. And then that will be able to, and optometrists can be able to use that data to further refer you to whether you need more investigation, you need a further, more expensive test. But something like this is very cheap to do, and it can be done almost anywhere. You just need a phone to do something like this. So that's the whole idea around it. And you can actually go even further. For example, now you have like thousands and tens of thousands of people who have already done the app, done the training, you can actually train on that data, and you'll be able to even get better predictions on what's wrong with the person. Cool. For people who are like interested in just like testing like the game, like the current one, I just did a build for this. What you have right now, it is the itest.netify.app. That's a simple version of it. So what you see right now, you can actually go to your computer and plug it in, and you're going to get the same test. Still in development, but yeah, that's what we have. Sure, cool. What about ethical consideration? Basically, machine learning is a powerful tool, but it also can be used for harm. Imagine all the data that you're gathering from people's medical results. So one of the problems with using other forms of ML or like other libraries is that you actually have to send the data to a server somewhere. That server is going to process that data and then tell you, okay, this is what is wrong. But the beauty of Tensorflow is that everything can be done on the client, so that means that all the ML inferences and training using the ML can be done in the browser. So nothing ever leaves the browser. So like the user's data is safe. So when you do a test on something like Tensorflow.js in the browser, all the data stays there. So it's actually very safe to actually use something like Tensorflow.js. Yeah, but I'll just like to end off with this quote, just like machine learning is the future of medicine. So there are many applications in medicine that can be like improved, or areas where I can use machine learning to improve medicine. So I think one thing I like about Tensorflow.js is that you don't have to learn anything new. There is new learnings, but then it's not something which is far off from what you're already using as a JavaScript developer. Thank you.